नंदिनी, आप सुन पा रहे हैं मुझे? नंदिनी जी,
हाँ जी सर।
250 प्लस के अराउंड में यहाँ ज्वाइन कर लिए हैं साइंटिस्ट ने। यूट्यूब पे भी काफी लोगों ने, 100-200 लोगों ने ज्वाइन किया। आई थिंक 400-450 लोग अपने पास हैं अभी, 450 प्लस। ठीक है, तो आप मॉडरेटिंग वाला पार्ट अपना स्टार्ट कर सकते हैं।
ओके सर। सर, am I visible and audible clearly?
यस 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 यस।
Okay, sir. Good evening, everyone. A warm welcome to all the participants joining us for day 4 of International Agriculture Workshop Come Training Mati 2025, proudly organized by AgriMeet Foundation Bharat in collaboration with our esteemed national and international knowledge partners. This side Nandini Sharma from AgriMeet Foundation Bharat, and I warmly welcome you all. Marti 2025, as well we all know, is our committed effort to transform Indian soils through modern, scientific, and climate smart agricultural approaches. Every day of this workshop brings us closer to future ready knowledge, innovation, and sustainable farming solutions. And today, for day 4, we are privileged to have with us an outstanding scientist whose work perfectly aligns with the vision and scientific spirit of Marti 2025. It is my honor to introduce our distinguished speaker for Marti 2025, Dr. Anjani Kumarji, an accomplished IIT Kharagpur alumnus and one of the India's leading researcher in soil water dynamics, greenhouse gas reduction, and climate resilient rice based systems. Dr. Anjani Kumar is renowned for being the first scientist to establish the relationship between soil water potential and greenhouse gas emissions. In eastern India, rice ecology using tensiometer based measurements. His predictive climate models have significantly improved global understanding of nitrous oxide emissions under changing CO2 levels. Our contribution deeply aligned with the climate smart vision of Marti 2025 to advance water productivity in rice under limited water conditions. He has innovated impactful technologies such as customized color coded tensiometer, NRRI, aerobic rice moisture sensor, eco friendly irrigation alert system. He has contributed immensely to the customized leaf color charts for nitrogen management, smart resource conservation technologies, urea briquette applicators, nutrient diagnostics kits, mobile based expert apps like Rice Expert and CSA Expert. His outstanding scientific leadership has earned him prestigious recognitions, including IPNI Award 2013, Nanaji Deshmukh ICR Award 2020 for outstanding interdisciplinary team research. Dr. Anjani Kumar's academic contributions include 75 plus research papers, 6 reviews paper, 20 technical bulletins, 17 book chapters, 3 books, 22 abstract articles, with a remarkable H index of 35, I-10 index of 67, and over 4,128 citations. He stands as an inspiration for the entire scientific community. With immense pride and gratitude, I now welcome Dr. Anjani Kumar Sir to deliver today's session under Marti 2025. Sir, we are truly honored to have you with us today and your expertise and presence with us. We request you to kindly begin your lecture. Over to you. The session is yours. Thank you so much, sir.
Thank you, Nandini ji. And I am also privileged to be in this group. And today I got the opportunity to deliver my lecture in this workshop, Marti 2025. And now I should share my presentation.
यस डॉक्टर साहब,
Yes,
यस यस डॉक्टर साहब, प्लीज।
Is it visible?
पीपीटी मोड पे कर लीजिए इसको प्लीज।
Yeah, yeah, yes. No, it is in PPT mode.
यस यस डॉक्टर साहब, यस डॉक्टर साहब, यस।
Okay. Okay. Then once again, I welcome you all the participants. And today the topic of my lecture is mechanistic insights into methane dynamics and strategies for mitigating methane emission from paddy fields. I am Anjani Kumar, senior scientist at ICR CRRI Cuttack, and first of all, we will know what is the importance of rice, why the world focuses on paddy cultivation. As we all see in this slide, that rice is almost harvested from 43 million hectares in India. Around 22% of the cropland is rice farms only, and the annual value of this crop is around 53 billion US dollars. That is 17% of the total crop value, and it also feeds around 65% of the population, grown by around 67 million farm families, that is 56% of the farmers. And rice is the livelihood of 150 million rural people, that is 40% of the poor population of the country. And it also consumes around 29% of the total irrigation water used in agriculture, and it also uses around 6.5 million tons of fertilizer, that is the 37% of the total fertilizer used in agriculture. And more important is that rice emits around 18% of methane from the total agriculture sector. Thus, it is quite visible that what is the importance of rice as in the economic scenario, when it comes to the generation of livelihood, and and also from the climatic point of view, that because it emits around 18% of the methane. And then what is the correlation between the rice and SDG, that is the Sustainable Development Goals of the United Nations? That rice is key to achieve the several sustainable goals, like goal 1, 2, 3, 4, 5, 8, 10, 7, 13, 14. Almost all the goals are linked directly or indirectly with the rice. Therefore, the world is focusing on the paddy cultivation, and there is a need to enhance the productivity, profitability, input use efficiency, and climate resilience. In the coming slides, we will see that what are the measures to enhance the productivity, profitability, and how to make the paddy cultivation more climate resilient. And this slide shows the major rice ecologies in India. That is the 1 minute, please. Yeah. That is the major ecologies in India. That is around 49% of the rice farms are irrigated, around 14% are rain-fed upland, 31% are rain-fed lowland, and 6% are flood prone. It means that we can see that rain-fed lowland, basically these are dependent on the monsoon rain. Here there is no or little irrigation facility is available, but this 49% comes under irrigated area means apart from the monsoon rain, the farmers are also having the facility of irrigation, and as and when it is required, they are providing irrigation to the rice crop, so that the increase is yield, the production is and productivity is also enhanced. Then what is the linkage between the Indian current carbon emission scenario and rice? We all know that rice paddy fields are an important source of methane emission, but what is the linkage? Here we can see that from our country, the total emission is around 3274 million tons of CO2 equivalent, and from agriculture sector it is around 17.8%. It means from the total emission, the agriculture sector is emitting around 17% of the emission, and from agriculture sector the paddy cultivation is the source of around 17% of the emission. The India currently emits around 3274 million tons CO2 equivalent, whereas the carbon sink capacity is 345 million tons. This is interesting that we are emitting around 3274 million tons of CO2, but the sink capacity is only 345. Therefore, the net emission from our country is 2929 million tons of CO2. That is, it comes around 4.9% of the global emission. And this is the matter of concern, because the gap is very big. and we have to minimize this gap. And in the next part of the presentation, we will see how we can minimize this gap. And again, this slide is showing that the emission is around 3274 and the sink capacity is only 345 million tons. And this is the gap. This orange graph shows the emission capacity, and this green is only the sink capacity. And we have to think, this is the point to think, that from how we can mitigate this gap between these two bars, how to mitigate the gap. That is how either we have to reduce our total emission or we have to increase the sink capacity. Then when comes the global methane emission scenario, that India ranks third in the top 5 GHG emitter countries. India ranks third after China, USA, and the position of India comes. It is the third top 5. It is the third GHG emitting countries, and this data is for the 2021. And when we see the world top methane emitting country from rice fields, India is second, only after China. That China emits the maximum methane emission from the paddy fields. After China, the position of India is with 4.90 million tons, TG, that is teragram. Okay. In terms of methane emission from rice sector, with an emission of 4.9 teragram, India ranks second. However, India holds sixth position in terms of per capita methane emission from agriculture. And Brazil is the first, United Nations is the second. It means that per capita we are emitting less, but in absolute term we are emitting more. And we all have heard about the nationally determined contribution target. Also at the 26th conference of parties, that is the COP, our prime minister gave the term Panch Mitra, that is the five-fold strategy. The first was that India will get its non-fossil energy capacity to 500 gigawatt by 2030. India will meet 50% of its energy requirement from renewable energy by 2030, and the reduction of the total projected carbon emission by 1 billion tons from now to 2030. That is, we have determined that by 2030, we will reduce our total projected carbon emission by 1 billion tons, and reduction of carbon intensity of the economy by 45% over 2005 levels. It means that what we were emitting in 2005, in 2030, we will be emitting around 45% less. So by far 2070, India will achieve the target of net zero. This is our commitment. This is the commitment of our nation at COP. Then coming to the carbon footprint of rice production in India, that here we can see that the average carbon footprint in India was 2.44 tons CO2 equivalent per hectare. And among the region wise, the northern India was the highest and the northeast India was the lowest. Among all the states, Punjab has the highest total carbon footprint for rice, that is 4.91 tons CO2 equivalent per hectare. It means that when we are growing 1 hectare of paddy field, how much CO2 equivalent GHG we are emitting. That Punjab has the highest value, this is the 4.91, and northeastern states has the lowest value, it is the 0.46. Here we can say that rice should be cultivated where the carbon footprint is low, and where the carbon footprint is more, those areas should be banned with rice cultivation. Then coming to the part of the mechanism of methane production from rice field, here we can see that in the basic chemistry we have heard about the term redox potential, and what is happening inside the soil. We all know that paddy in lowland paddy field or submerged paddy field, there is a standing water, 3 to 5 centimeters standing water is there, and when standing water is there, the process, first of all, oxygen is reduced to water, then comes the number of nitrate, then manganese, then iron, then sulfate, and then CO2. Whatever CO2 is available in the soil, it is reduced to methane by the action of several bacteria like Methanococcus, Methanospirillum, and Methanobacterium. And this formed methane is liberated into the atmosphere, and it is causing the pollution, it is causing the climate change or global warming, whatever is in there. And it happens when the redox potential comes below 200, comes in the range of minus 200 millivolt. And here we can, in this slide, we can see that what is happening, that here soil organic matter is there. By the action of methanogenic bacteria, it is reduced to methane. And once methane is formed in the soil, it has three escape route. Either it is directly diffused in the atmosphere, or in the forms of air, in the forms of bubbles, it is evaluated in the atmosphere, or with the help of paddy plants, rice plant gives a passage to the methane emission. It is coming into the atmosphere. And what we can see that in this, here we can see that diffusion is less than 1%, evolution is less than 20%. The major chunk is the parenchyma mediated transport, means the rice plant mediated transport. It means this shows the importance of rice for the emission of methane from the paddy fields, because once the methane is formed in the soil, again the methane, again one group of bacteria acts on it, and it is again transformed into carbon dioxide or some non-methane form of carbon. But when there is a we grow paddy plants, the paddy roots, the roots of the paddy are hollow, and they give a passage to the methane. That methane gas, with this passage, it is liberated into the atmosphere, and the percentage we can see, it is 60 to 90%. Therefore it is important to study how rice plants are helping in methane emission, or that is the parenchyma mediated transport of the methane from the soil to the atmosphere. Then how we measure the greenhouse gas emission, that is the methane emission? There are three techniques. First is closed chamber technique, second is eddy covariance technique, and the third is the process based models. In the closed chamber technique, there is a base plate fixed in the soil, and inside the base plate there are 6 rice hills. On the top of the base plate, this is a chamber made of the perplex glass, and it is kept right, what we are seeing in this picture. This boy is collecting the greenhouse gas samples. This chamber is kept on that base plate, and at periodic interval the greenhouse gas samples are taken. First sample at start of the sampling, that is a 0 minute, the second at 15 minutes, and third at 30 minutes. And the second technique is the open path eddy covariance system, and this is a machine, but it is a costly machine, costing more than 1 crore, and it gives the real time. It is a system, and it gives the real time measurement of the methane, nitrous oxide, and several other gases, but it is a costly instrument. And these are the advantages and limitations of these systems. And again, there is an indirect method that is called the process based modeling, like the FC model, DNDC model, Descent model, and the GUESS models. These models also, because with the help of different algorithm, we can predict that how much methane is emitted from a particular paddy field. And one of the best model is the DNDC model. And in details we can see that how this model is working and how to calibrate the model. Then the question comes, are rice fields a source or sink for carbon emissions? Here we can see that, okay, what is the carbon input and what are the carbon output? The carbon input in the rice fields are net ecosystem productivity, root and stubble biomass, aquatic algal biomass, rhizodeposition, and compost. By these means, the carbon is added into the paddy field. And what are the outputs? First, the CO2 emission, the methane and nitrous oxide emission, the carbon removal at harvest. What we are harvesting, the paddy plants we are harvesting, the stem is containing carbon, the grain is containing carbon, roots are containing carbon, and carbon lost as a dissolved organic carbon. And with the help of water, what is present in the paddy field in the form of dissolved organic carbon, carbon is also lost. Then we have to see that these are the input part and these are the output part. Then where is the balance? How the rice fields are acting, whether it is a net source or it is a sink. Then here we can here several researchers have proved that rice fields are a source rather is sorry are a sink rather a source for the carbon for the carbon storage, because whatever carbon input is there, because when rhizodeposition is there, that carbon is added in the soil and it remains there in the form of soil organic carbon. It is sequestered for a long time and it remains in the soil for a longer period. Then what are the strategies for mitigating methane emission? That there are some practices like traditional practice and modern practice. That that we all know that paddy fields are emitting methane. Then what are the ways out, that how we can minimize the methane emission? The traditional practices: first, double rice cropping. That is, this system is nutrient depleting and more emitting. That because when we are growing rice in both in Kharif and Rabi season, the emission of methane will be more. Puddling and transplanting. Puddling and transplanting, in that what we are doing, we are maintaining standing water in the paddy field, and when standing water is there, the redox potential of the paddy field is going up to minus 150 millivolt, and there is a net formation of methane, and that methane is emitted into the atmosphere. That is the blanket fertilizer application. It means that we are applying fertilizer more than it is required. Suppose your field is needing 80 kg of nitrogen, but we are using 100 kg of nitrogen. Then the excess nitrogen is emitted in the atmosphere in the form of nitrous oxide, and it is again contributing to the climate change and greenhouse gas emission. Then flood irrigation. We are all giving water because we have the luxury of water, and we are giving the flood irrigation. Means we are providing more water what is required by the plant. Therefore the water productivity is low, and it also contributes to the anaerobic condition in the paddy field. Therefore net emission of methane is there. And we are growing traditional variety. Under the traditional practices, we were growing the traditional varieties what our forefathers were using. And those varieties are in the modern research, researchers have found that because of the presence of more Erenchyma species, these varieties have more capacity to transmit methane from those, and ultimately those methane are coming in the atmosphere. Now coming to the modern practices, means that what we have done, what the agricultural scientists had achieved, so that to replace these traditional practices by the modern practices to minimize the methane emission, or for rice decarbonization. The more appropriate term is rice decarbonization. The first approach is diversifying the second rice crop. It means traditionally what we were doing in eastern India, rice after rice, but now no rice in the Kharif season we are growing rice, but in Rabi season we are diversifying the second rice crop by millet, oilseed or pulses. And due to this effort, the methane emission from the Rabi crop, if we are growing rice crop, the methane emission is more. But if we are diversifying the second rice crop by millet, oilseed or pulses, the net methane emission is coming down. The second approach is the DSR, that is the direct seeded rice. What we were doing in the traditional practice, we were puddling the field, we were going for transplanting, and we were maintaining standing water in the field. Therefore, the methane emission was more. But when we are adopting DSR practice, in DSR, we are directly, with the help of seed drill, we are directly sowing dry seed in the dry field only. Therefore, there is no puddling, no transplanting, and no maintenance of standing water, and therefore the methane emission is coming down by at least 40%. In DSR practice, we are mitigating the methane emission by around 40%. And then the 4R stewardship of the nutrient management, that is the 4R is for right way, right type, right dose, right time. Here what we were doing, we were giving the blanket fertilizer application, and here we are site-specific nutrient management with the principle of 4R stewardship, and it is again cutting down the use of chemical fertilizer, basically the nitrogenous fertilizer, and therefore the emission of nitrous oxide is coming down. Similarly, the AWD practice. In place of flood irrigation, we are practicing nowadays the AWD practice, that is the alternate wetting and drying, with the help of sensor-based irrigation seedling machines or drip or sprinkler, and therefore we are not maintaining the anaerobic condition or the standing water condition, and therefore the methane emission is also coming down. And now the improved or hybrid variety. The researchers have identified some varieties which are less emitter of methane, and by growing those variety we can curtail the emission of methane by around 20%. Then ecology wise, because rice is grown in at least all the ecology, the irrigated ecology it is 22 million hectares, the rainfed upland ecology it is 6 million hectares, the rainfed lowland is around 14 million hectares, and the flood prone is around 5 million hectares. Then what would be our opportunity, would be our approach for mitigating the GHG emission? In irrigated ecology, we can go for DSR, alternate wetting and drying, crop rotation, balanced fertilization, soil amendments, methanotrophs, and nowadays methanotrophs are coming in a big way. Our institute has also formulated a methanotroph, formulation of methanotroph, and the application of these methanotrophs is minimizing the methane emission by around 10%. And in rainfed upland ecosystem, we can go for DSR and crop diversification. In rainfed lowland condition, the mid-season drainage and the balanced fertilization may be a good option for the GHG mitigation, basically the methane mitigation. And in flood-prone or deep water ecology, we can go for green manuring and the application of the soil amendments. Here we can also see that that by the adoption of DSR, we have the opportunity to mitigate the methane emission, and the improved nitrogen management, that is the application of the slow release fertilizers, the real-time application of nitrogen fertilizers like CLCC, that is the customized leaf color chart, and Android based nitro. There are so many apps nowadays also available. That is the rice, one of the app is Rice N Expert, and we can also use the CLCC, that is the customized leaf color chart. By the help of these instruments, we can provide the nutrient, basically the nitrogen to the plant at the right time. When the plant needs most, we will supply the nitrogen or urea at that time only. Therefore, the use efficiency of the urea is increased, and the emission in the form of nitrous oxide is decreased. Similarly, practicing alternate wet and dry with the help of this pani pipe. This pani pipe is a plastic pipe, perforated plastic pipe, and it is inserted in the field, and we are regularly monitoring the water level inside the pani pipe. When the water level goes below 15 centimeter, or for some soil 30 centimeter, then only we re-irrigate the field. And by the practice of this, again there is a potential to mitigate the methane emission. Then conservation agriculture practices and agroforestry. These are some of the measures to mitigate the methane emission or nitrous oxide emission, or in total we can say the greenhouse gas emission from the paddy fields. Then we will see in detail how by modifying the hydrology of the rice field, we can cut down the methane emission. That here we in both side, one side we are seeing the traditional flooded rice, and one side the alternate wetting and drying method. What I have told in the earlier slides, that AWD method has the had the potential to mitigate the methane emission by around 30%. Here what we are seeing, that when flooding happens, it cuts down the oxygen supply to the rhizosphere, and the EH, that is the redox potential, goes below minus 200 millivolt. When the redox potential goes below minus 200 millivolt, then there is a anaerobic decomposition of the soil organic matter by the help of methanogens, and methane production is there. It means that when the organic matter decomposition under anaerobic condition, the certain group of bacteria like methanogens produces methane, and that methane is liberated into the atmosphere. But let us see what is happening in the AWD condition, that is the alternate wetting and drying condition. Here in the traditional flooded condition, we will see that the height of the standing water is more. But here AWD, the height of the standing water is low, or we can say there is no standing water because this water is inside the soil. In AWD condition, there is a no anaerobic condition. There is a aerobic condition, means there is an influx of oxygen in the soil, which prevents the falling of redox potential to the range of minus 200 millivolt. And when the redox potential is not going so less, the activity of methanogens is suppressed. Therefore, the production of methane is also minimum or lower down. When the production is low, the emission will also low. Therefore, there is a equilibrium, that when we will go for that flooded rice cultivation, the methane emission will be more. Why? Because there will be an anaerobic condition, the activity of methanogens will be more, and therefore the production of methanes will be more. But under AWD condition, because there is no standing water, therefore the EH never goes up to minus 200 millivolt, and therefore the production of methane is low, therefore, and also the emission of methane is also low. Then we can see that okay, there is a trade-off also. Trade-off means under AWD condition, the methane emission is less, around 23% less, because this research was published by Kumar et al. 2016. But there is more nitrous oxide emission. Therefore, the overall global warming potential is only minimized by come down by around 22%. There is a trade-off, because there is a decrease in the methane emission, but there is also a slight increase in the nitrous oxide emission. And GWP considers the both methane and nitrous oxide. Therefore, the decrease in GWP is not so much. It is only 22%. Therefore, we have to find out the balance point, that okay, we have to find out in the AWD method, then when to wet the field or when to re-irrigate the field, so that the methane emission is also down and the nitrous oxide emission is also down. And that point, under that point, if we are devising our water management strategy in the paddy fields, the overall GWP, that is the global warming potential, will also come down, and it will be a win-win situation for all of us. Now, the DSR technology, as we have also seen in the earlier slides, that DSR is also technology for methane reduction. And DSR is normally three types: dry direct seeded, wet DSR, and water seeding. And in dry DSR, it is mainly practiced in the upland situation, and wet DSR is also practiced in both the season, dry season and wet season. And we will see that how it is affecting. In this table, we can see that under DSR condition, when it is compared with the TPR, that is the transplanted puddle rice condition, the irrigation water productivity was around 26% higher in DSR, and the energy productivity was also around 16% higher in DSR, because we are in a DSR, we are providing less water to the rice field, and but the yield is at par. Therefore, the irrigation water productivity is higher in DSR as compared to the TPR. And then we can see the GHG emission. The GHG emission we can see in a DSR condition, the methane emission was reduced by around 30%, and around 30%, and as compared to the transplanted rice condition. But there was also an increase of nitrous oxide emission by 10%. Therefore, the cumulative nitrous oxide emission was 16% higher in DSR AWD as compared to the transplanted puddle rice condition. Then the precision nitrogen management for reducing nitrous oxide emissions. Here we can see this is CLCC. The person is holding customized leaf color chart, and this shows that in this slide we are seeing that this farmer is matching the leaf color with the color of the LCC. And when it matches at the point number 3, then it is suggested to apply the urea or the nitrogenous fertilizer. And then we can see that CLCC, and this is a Android based app, that is the Rice N Expert from Google Play Store. You can download this app. This is a free app, and when we apply nitrogenous fertilizer based on the CLCC reading or the Rice N Expert, we could mitigate the nitrous oxide emission by around 11%. And now coming to the rice varieties, as earlier I have told that rice varieties are not producing the methane, they are only helping the transport of methane. What the methane is produced in the rice soil, that is transported through the rice variety because the stem is hollow. The presence of more Erenchyma helps the rice plant to transport more methane. Therefore, and when it is compared between the duration of the rice varieties, the short duration, that is the 118 days variety, and the long duration 145 days variety, that is long duration variety emits more methane as compared to the short duration varieties. And okay, when we imagine that, okay, what would be the idiotype of the plant, what would be the desired traits of the plant, so that those plant or varieties could emit less emission. The first criteria is the plant should have less stomatal frequency. The second is limited Erenchyma, because the Erenchyma is the path which transports the methane from the soil to the atmosphere. When there is a limited Erenchyma in the plant variety, the transport will also low, and that variety will considered low methane emitting rice varieties. High radial oxygen loss. It means when the rice soils are having the anaerobic condition, but there is a leakage of oxygen through the rice roots. And when there will be leakage of oxygen, the condition will become aerobic. From anaerobic, it will become aerobic. And under anaerobic condition, the methanogenic bacteria is dominating, but under aerobic condition, the methanotropic bacteria is dominating. The methanogenic bacteria helps in the formation of methane, but the methanotropic bacteria helps in the consumption of methane, that is the transformation of methane to non-methane carbon form. Therefore, the variety having the higher radial oxygen loss will emit less methane, because there will be aerobic condition in the soil, and the formed methane will again be transformed into the non-methane carbon types. Then high sink strength in the above ground part, because everything is related with the carbohydrate. When there is a more carbohydrate mobilization in the root parts, there will be more rhizodeposition, because that is the secretion of the carbohydrates by the root, and these secretions acts as a food material for the bacteria, for the methanogens. And when the activity of methanogens will be more, the formation of methane will be more. Therefore, if the high sink strength is there, means high bold grains are there, more number of grains are there, more carbohydrate will be deposited in the grain part only, and therefore less rhizodeposition will be there, and the activity of a methanogenic bacteria will be less. Then similarly, the optimum medullary cavity, the reduced starch allocation to roots, reduced root biomass, optimized root depth, and optimized root porosity. We can design a rice plant with these traits, and that rice plant will become a low methane or low carbon emitting rice plant. Therefore, in this time or in the coming time, there is a need of this type of plants. We have to grow rice because we need rice. Our population, our 65% population's staple food is rice only. We have no way to no way another to grow rice. We have to grow rice, but we have to design rice varieties in such a way that we are getting the grain, but that variety is emitting or transporting less methane, and this is the need of the time, and researchers are working in that direction, and so many breakthrough has also they got. Then coming to the crop diversification, means when if the cropping system is rice, we have to diversify the second rice crop with non-rice crop like maize, oil seeds, millets, and then we will see that when there is diversification, when there is rice system, the GWP is around 19,429. But when the second rice is replaced by maize in rice-maize system, the GWP significantly comes down. Therefore, we can say that this is a better way to mitigate the GHG emission from the if we are switching the second rice crop with non-rice crop. here we can see the rice emits around 4,000 kg CO2 equivalent, whereas methane emits only 1,500 and wheat only 1,700. Therefore, as compared to rice, the maize and wheat emits significantly lower amount of greenhouse gas. Therefore, there is a need to diversify the second rice crop with non-rice crop. Then sustainable intensification by inclusion of legume, and in this table we can see the same thing, that diversification of rice fallow by inclusion of oilseeds or pulses. And it also adds to the system productivity, and the inclusion of the oilseeds or pulses is also environmentally sustainable because it emits its carbon footprint is lower as compared to rice, and it emits less greenhouse gas as compared to the rice system. Similarly, the conservation agriculture, it is also a practice for mitigating methane emission, and the zero tillage based systems significantly lower down the GWP and higher carbon sequestration potential as compared to the conventional system. In this table, we can see this was published by Munda et al. 2028. The CT is the conservation tillage, DSR, conservation tillage, green gram. Means conservation tillage followed by DSR followed by conservation tillage, green gram, the GWP is this. But when it is when the practice is zero tillage, TPR, zero tillage and the green gram, the GWP is coming down significantly. Then we have heard the term Har Made Per Paid. This is a mission on agroforestry by the government of India and also the several state governments. What this mission is telling, that on the bunds of the rice field, you grow the agroforestry trees. And these agroforestry trees has a potential to capture the carbon. The atmospheric carbon they are capturing and storing in the soil, and thus the global warming or the climate change, they help in mitigating the global warming or climate change. And the data shows that for a 1 hectare crop agroforestry model with trees like Acacia equiliformis, Aja dialectica, indica and Dalbergia sisu planted on the field once, there is a total carbon sequestration of around 78 tons CO2 equivalent per year. And the government is also giving so much subsidy on this, that on the bunds we can plant the agroforestry trees so that the capture of carbon is there, and it also helps in the mitigating the methane emission or the global warming, and also helps in keeping the climate cool. Then one of the important thing is harnessing the potential of the methanotrophs. Earlier, we have seen two types of microorganisms related with the methane dynamics, the methanogens and methanotrophs. Methanogens means methane producer. They produce methane. But methanotrophs means methane consumer. They consume methane. Once the methane is produced, and the methanotrophs act on those methane, and they transform that methane into a CO2 or other form of carbon. Therefore, the application of methanotrophs result in a reduction of methane emission by around 13.88%. And so many, our CRRI is also working in this field. Several private companies are also, they have also developed methanotroph formulation, and the application of this methanotroph formulation, it is helping in mitigating the methane emission. Maybe the percentage is different. Some is claiming more than 20%, some are claiming around 10% only, but it is working. And this is also a proper method, green method, that by harnessing the potential of the microbes, we can mitigate the methane emission from the paddy fields. Then a term is cable bacteria, and some of the Chinese scientists, what they found, that there are a certain group of bacteria in the paddy soil called the cable bacteria, and they found that application of the cable bacteria also led to a significant reduction in methane emission. The number was more than 50%. And in India, people are also working on this cable bacteria, and hopefully some formulation will come in the coming time, so that the cable bacteria formulation is also a helpful to mitigate the methane emission. Then coming to the conclusion, that yes, the methane emission from the paddy field is a matter of concern, but with the modern techniques of paddy cultivation, there are ways like DSR, AWD, low methane emitting varieties. We can mitigate the methane emission. We can harness the we can harness the potential of bacteria, microbes like cable bacteria or methanotrophs, and we can also go for crop diversification, the growing agroforestry trees on the bunds, and so that we know the basic chemistry of methane formation and its transport with the help of rice plant mediated transport. And by knowing these chemistry, by knowing these mechanism, we can do further research, we can do further innovations, so that the formation of methane in the soil is lower down, and the transport by the paddy plant, that is called the plant mediated transport of methane from soil to environment, is also cut down. And by the adopting these practices, we can make rice farming with lower methane emission, and we can call that green rice farming. That is, the methane emission from the paddy fields is lower down, and thus we can we can think for a environment with low methane from the paddy fields. And one thing is also nowadays it is coming. I have not given in this current slide the carbon credit, the concept of carbon credit, because when there is a mitigation of methane or carbonaceous gases, one carbon credit means 1 ton of carbon dioxide, either it is captured or it is less emission. It means that if we are mitigating 1 ton of CO2 emission, it is equivalent to 1 carbon credit, or if we are capturing 1 ton of atmospheric CO2 and locking it in the soil, it is also equivalent to 1 carbon credit. And now in the world, the Vera and the gold standard companies are coming in a big way. Our government of India is also coming with CCTS for the carbon trading and the carbon markets, where we can trade the carbon like Kisan Vikas Patra or Indra Vikas Patra. We can trade the carbon like because these companies are giving us a certificate that is called as the carbon credit. If I am a farmer and with 1 hectare of land, I am mitigating, suppose, 4 tons less CO2 as compared to the other farmer, then I will get the 4 carbon credits. And these carbon credits will be marketed in the international market. And approximately 1 carbon credit is costing around $40. And if I am generating 4 carbon credits with 1 hectare, I am generating around $160. And this is a huge benefit, economic benefit for the farmer, because the farmer is not doing any extra thing for this. Only he is adopting the low methane practices or the smart agriculture practices, and he can also generate the carbon credits. And with this slide, I am coming to the end of my presentation, and now the presentation is open for discussion. I will be happy to have your questions and answer those things. Thank you.
Thank you so much, sir, for the wonderful session. I may now request everyone to please put your questions in the chat box, or if someone directly wants to talk to sir, they can talk to him directly.
गुड इवनिंग सर। हेलो,
गुड इवनिंग।
मेरा नाम श्रीहरि बुर्ला।
ओके,
साइंटिस्ट सॉइल साइंस।
ओके,
सो मेरा बहुत बढ़िया
आप आपका आवाज ब्रेक हो रहा है, आपका आवाज, यू आर नॉट ऑडिबल, यू आर नॉट ऑडिबल, कैन यू राइट इन द चैट बॉक्स?
चलिए, आपको
You
बहुत
please
बहुत
write in
धन्यवाद।
chat box.
नमस्कार।
Your voice is breaking. Please write in chat box.
ओके ओके।
Admin, please mute him.
Good evening, sir.
Good evening.
Sir, I am Kirot Chandra Sahu from Department of Soil Science.
Which university?
Sir, Dr. Rajendra Prasad, Central Agriculture University, Pusa.
Okay, okay, please tell me.
Sir, tell me about some carbon credit related initiative taken by Government of India.
Okay.
How will be helpful in future for the reduction of the emission of carbon dioxide, and what are the current trend and the future prospect? Please
Okay.
tell me.
Okay. Right now, there are two big players in the field of carbon credit. One is European company, that is Vera, and Gold Standard, and one is American company, that is the Vera. These two companies are the major players in the field of the carbon credit. But from last year, Government of India and BEE, that is the Bureau of Energy Efficiency, has came up with CCTS, carbon credit trading scheme, that is totally made in India, and the regulations and the rules are total keeping the condition of the Indian farmer. They have formulated the principles, rules, and all the regulations. CCTS is coming in force from 2026. Once CCTS will come, the Indian farmers, the registry of carbon credit from by Indian companies will be a little bit easier, because you are asking about the future prospect. The future is the carbon smart farming, or the you can tell the practices which are emitting less methane or less greenhouse gas emission from the farming, from the farmers field. The future depends for those only, and if you are adopting those practices, there is a generation of carbon credit. But we should be careful, because those carbon credits needs to be verified by independent inspectors and independent companies, and only after that verification, that is a troublesome process, and if it is verified, you will get the carbon credit, and which will be tradable in the international and national market. And it is coming in a big way from next year. The Indian schemes are also coming. Right now we are having the two companies, the two major big players, that is the Vera and the Gold Standard. They are the certifying agencies, and several private companies like Grow Indigo, Mitsubishi, Bayer, they are also they are the developers of the carbon project. They are not the certifiers. That's right now the certifier is only the two, Vera and Gold Standard. And from the next year, our own country will also be the certifying agency with the help of CCTS scheme. Thank you.
Okay, sir. ठीक है, thank you, sir. Sir, it is possible for the small and marginal farmer, because in India most of the farmers are small and marginal.
Yeah. For small and marginal individual farmer, it is not possible. But when you come with a group, suppose 100 farmers are making a group, then it is possible. But isolated farmers cannot go for the carbon business or the carbon credit business. Okay, because the cost is also involved. Na? The verifier will take money from you, and therefore it is always suggested that you come in a group, at least 100 farmer group, then only it is possible and profitable also.
Okay. Thank you, sir. Thank you so much.
If still anyone have any query, you can directly ask or you can type your questions also.
Evening, man. Please, madam, it will be helpful for us.
Oh, I think if there is no question, then I thank the organizers for inviting me in this MITI workshop, MITI 2025 workshop, and giving me the opportunity to interact with the participants. I am seeing around 253 participants in this Zoom meeting, and I think the questions I am also seeing, and I will try to answer all those questions in the chat box. And thank you, organizers, for inviting me, for giving this opportunity to present my work and also interact with these intelligent people. Thanks a lot.
Thank you so much, sir, for your presence and on the behalf of AgriMeet Foundation Bharat and the entire team of MATI 2025, we extend our heartfelt gratitude to you, sir, for delivering such a powerful, insightful, and deeply scientific session today. Since, sir, matlab, your clarity and your depth of research and your practical innovation have truly enlightened our participants. The knowledge you shared today will help young researchers, scholars, and professionals will make more informed decisions in nutrient management, water productivity, and climate resilient farming. We are truly grateful for the time you dedicated to us today and for enriching MATI 2025 with your expertise. Thank you once again, sir, for your valuable contributions and inspirational presence. Please be connected to AgriMeet Foundation Bharat for any future academic activities. Thank you so much, sir.
Thank you. Thank you.
Everyone, you can leave the session now. Thank you so much.